Assume we have a fulcrum here. The last week I was still working on the test-based strategy test, and I have a new failure. I'm pasting it in the chat window. Let's check. And apart from it, I create some PR to do the cleanup in the recovery related code, and also trying to get Crimson Pass two tests. One is the test underscore redos.py, another is a Ceph underscore test underscore admin socket output. So that's it. Achame.
Yeah, so extend map tree has already updated for some days, and so please review it. If no problem, please approve and merge in. And I'm debugging on the old map tree code currently. The features is almost done, and I'm doing the debugging and the test case current.
Thank you. And Riddick.
Not much for Crimson. I'm mostly focused. I'm almost exclusively focused on offloading the on-map stuff in RGW. However, for Crimson, a bunch of reviews, and especially the review of Szechuan's interruptible errorator. That's me.
Ronan.
Hi everybody. Mostly reading code, reading PRs, and copying diagrams of scrubbing from paper to computer forms. I will, when I'm finished, I try to incorporate, at least share those with you, incorporate in the documentation. That's it for me.
And just out of curiosity, what tool are you using for illustrating the diagram? Using data or something?
I'm using Lucid Charts. I got a license for Lucid Chart now.
Okay, thank you. Sam?
I think I have basic space accounting working. I have to do some debug related to that, so I'm on to doing segment scanning and cleaning. That should be it.
Thank you. Shuhan.
Last week I was still improving the interruptible iterator feature. The coding is almost done now, but yesterday I had a small discussion with Radek, and it seems we have an issue about running iterator feature and SeaStor feature simultaneously, and I think maybe we can discuss it later in this meeting. And that's all for me.
Okay, we can do that. Yingxin?
Yeah, last week I reproduced and fixed the heartbeat bar, and I have integrated to the SeaStor the ONode tree implementation to SeaStor logical cache extent and transaction manager. And I think it is a milestone, and I will summarize the current status and send out a PR for review.
Fantastic, thank you. By the way, Yingxin, I've been spotting some test failures recently in the unit test of a messenger, SeaStor messenger.
Okay.
Did you get a chance to see to look into it?
Yeah, do you have a link?
Sure, I will send a link offline to you.
Okay.
And also, as you ping you over the GitHub, there are two occurrences of them. So I think it's probably the regression after you fix the unit test
Oh, I will take a look.
Thank you. I will ping you with a backtrace and error message in an email. Ritek and Shihan, do you want to continue the discussion on the interruptible iterator?
Sure. Yesterday's evening I posted a GIF exemplifying the problem I'm seeing with the current implementation. Let me paste it. It's here. I think that okay. A little bit more background. The error rate, the interruptible error rated code makes an assumption about some synchronization provided outward, provided by the user. Usually it's fine, but there is the case of multiple requests coming from multiple sessions and targeting multiple different PGs, where we know, as far as I understood, where we offer no synchronization at all. And when the error-rated features are combined with SeaStor vanilla features, it could lead to trashing the interrupt condition stored as a thread local, actually stored as a static single member of English memory. That's the issue with the implementation. However, I am afraid that there is a much more fundamental issue with the concept at all. Actually, after the change set, error-rater is not pure error-rater anymore. I mean, it gets additional responsibilities. My feeling is that it should be actually renamed. Error-rater and interruptator would be the name, pointing now the purpose after the change set. We are mixing responsibilities. One component, pretty complex one, got multiple responsibilities. I'm not sure it's the way to go.
The basic idea in the original discussion was that we have the error and the error futures there anyway. So, and we will replace all SeaStor futures, error futures. So, seems a logical point.
No way. Original idea about mixing the different levels of erroration was that a less errorated future can be always let's say moved to more errorated future. Vanilla SeaStor future is a special case here. It's actually a special case of it's the least error-rated future from the point of view of error-rated.
I'm with you on that one, Reddick. But more practically, so we do need to be able to mix interruptible futures and error-rated futures, because we kind of expect nearly every process to be error-rated. And there are very, very few things in Ceph that don't involve I/O in some way. So all of them need some way of propagating exceptional outcomes. And at the same time, there are very, very few processes in Ceph where we don't want a way to interrupt the callback chain. So there just aren't many cases where we need one but not the other. We kind of always need both.
I see. I see. In other words, gluing the extra responsibility to a writer is pretty attractive because it's got widespread.
Hang on. I'm not. That is unattractive. I'm with you on that. I don't really love one component having two major responsibilities. I do agree with you on that. But we need a way to address the fact that we do often need both. So
agreed.
It won't be easy to predict up front. So we want it to be the same way with an error rater. You can kind of declare, oh, it's this error rater set for this function, and then add another one to it later, and then have the compiler tell you what you have to fix. We kind of want the same process here. So all I'm saying is consider the developer burden, I guess, or how it will actually feel.
And that's the reason why. Hang on a moment. That's the reason why I started thinking about turning the error rater, the class, it's the current class we have, into some kind of a base class. Let's say hookable error rater. I would love to have a clear division between the responsibility, to put some kind of interface for gluing extra functionality, extra features to the writer. Because
I think that's where this started, right? That it was difficult to do because you necessarily need a way for something that is interruptible to call into something that isn't, or vice versa. That is, the handling chain itself has to be agnostic. It can't care what the intermediate calls return because it needs to be able to handle the worst case, which is that interruption is possible. In other words, I understand what you're saying. What I'm saying is, but it's only useful if it's actually possible. There are practical reasons why that has turned out to be hard.
Sorry, can you repeat the last thing? Not sure whether I got it entirely.
There are practical reasons why the thing you were describing has turned out to be hard.
I see.
I'm fine with it, but I'd like it in PR form, I guess.
Okay. Practicality wins. Sure. But before going with that, let's reiterate the original problem that led us to touching error rater. I saw that when it comes to the interruption, we actually glue two different extra responsibilities. One is about the graceful shutdown. Sure, it's stopping. That's part of stopping PG. But the second one is about snapshotting the PG epoch and ensuring it hasn't changed. When this
Radek, that's not all. In SeaStor, for instance, you might need to be able to cancel ongoing operations going into the journal if you're doing a rollover and force them to retry. Literally any case where a pending chain of where a class of pending chains of operations need to be able to be canceled or need to be able to check a condition every single time they wake up. It's that entire class of problems. It's not just two problems.
Okay, so I see. We expect even more. Okay, I was thinking about the third one, which is actually, SeaStor fork some time ago, maybe 2 months. They changed the interface, the public interface of Future. It doesn't care about starvation. It doesn't call needs preempt anymore. It's a responsibility of user at the moment. So I bet that sooner or later we will need to, with at least third use case for gluing third responsibility for gluing into a writer. It will be about interrupting too long continuation chains. But well, if you are saying about SeaStor, I'm not surprised we will need a fourth. So maybe we should rethink the idea of hooks in error rater. And the interruptator will be actually one of the variants, one special case of hookable aerator instance with some particular hooks provided. Not sure whether it's doable. Just loudly thinking.
Doable, probably doable, but with some performance loss, always.
Yeah. Boils down about our restrictions and requirements of the hooks. Yes, sure, we could put an STD function there, but you know it won't be super fast.
We could specialize this if there is no like empty, like we have a like empty function predicator passed in, or there's non-predicator passed in. We can just skip it at the right time.
And the last change set from session 1 actually introduced if const exp check for the empty interruption condition.
Do we need to support like multiple predicators in machinery if you wanted to have a like pluggable system for aerator which supports one or more predicators? Do we need that?
I think there might be a possibility or the need to do that. We might need multiple predicators.
But okay, what worries me when it comes to just practicality, pure practicality, it's how do we ensure? Okay, the current interrupt condition hooking requires not mixing with SeaStor future at all. It would mean that only aerator needs to handle literally everything. I'm not sure it's doable, to be honest. Okay, maybe we could change the vanilla SeaStor future, but it means actually convincing Avi and company to introduce some hooks to SeaStor future, which could be quite hard, I am afraid. They are really focused on its performance. They cut off even the needs preempt check. On the other, as an alternative, we could fork our. We could add more patches. Yeah, I'm seeing your mimic.
So it's intrusive even down to SeaStor level, right?
Yeah.
Oh, that.
What if we instead replaced tasks in SeaStor?
Tasks in SeaStor, sorry?
So there's a higher level struct above futures, right? That is the actual scheduler interacts with, I think it's like a task structure or something that encapsulates futures, the future chain.
But that machinery is embedded into SeaStor, the tasks.
I'm saying, what if we proposed a refactor of that allows a user to hook into that level and replace future completely?
Okay, you are thinking about what session there is when it comes to Ceph. Then I'm still speaking about the session in current implementation. In Ceph, then Ceph is implemented in that way that it's actually an overlay over then wrapped of vanilla future, and we are passing some extra lambda there. This lambda is used by session 1 to make to capture the interrupt condition and to restore it when executing the high level. Yes, sure. This actually it's some kind of guard for task switch in a reactor. If we could get some hook inside the reactor, in the task switcher, and the guy who is responsible for switching tasks, we could move we could move the restoration of the count interrupted there.
No, that's a bad idea. What I'm saying is we replace, so I don't know, I'd have to look into it, but I suspect there's a thing, in other words, I don't think the reactor deals in futures directly, it deals in tasks. And tasks are some kind of a
tasks
abstraction over future types, and that doesn't have to be true. You could represent any number of things that way.
Agreed. Reactor works on tasks. If somebody calls SeaStor
Right.
future,
So saying,
then
hang on. I'm saying you can refactor that the way that relationship works to allow a task that is not composed of futures at all. A task that is composed of something else, something the user provides.
Anything callable?
It would have to be It would have to look like, are you done yet? Are you done yet? Are you done yet? Until you're done, right? I think that's what the interface looks like, and a way of polling for ready to go for the next thing. So it's a kind of a combination of replacement with promise and future. But I'm wondering if a refactor like that might be possible. It's much less invasive potentially if it's already decoupled that way. It would just mean that we would have to basically replace future with our own implementation. But we'd be able to do it, hang on, but we'd be able to do it without forking SeaStor. And don't raise your nose at replacing future. It's not core to SeaStor for a number of reasons. First, the new coroutine stuff in C++, whatever, doesn't use futures, right? That implementation in SeaStor will use something else. The same would be true here. Like, I don't want to not do things because future is annoying, right? That's not a good reason.
Okay, my point here is future is actually pretty deeply embedded in the utility library of SeaStor. Into things like do-with, parallel, for each, all that library. So it's it's exchangeable, but the amount of work is might be bigger than we initially think.
Oh, fair enough.
I encountered that issue when working on Iterator. The library is pretty expensive. However, quite likely we can exchange the future component. And to be honest, it seems as the only way you are as understood your concept. You are thinking about introducing some extra hooks at the level of SeaStor task. But who is responsible for creating a task with a continuation? In the case when then is called on unfulfilled future, is actually the SeaStor future. So you would need to change that.
Like a factory of the new features.
Guys, could we write down all the use cases
Radek, there's only one
the interruptions for
this isn't complicated. There needs to be this is true throughout the existing OSD code. Basically, every time we take a lock, we have to check for things still being valid. In the PG, it's almost always the OSD epoch. In the OSD, it can be a few things, but one of them is that the OSD map we still have is still valid. In I don't remember what it is in BlueStor, but there's something analogous. It's just there needs to be a way every time you wake up and take control back at the beginning of a safe then to check a condition and not have to repeat that condition every time. That's it.
Sam, I don't agree with you. It's not.
What else?
It's not necessary to check the precondition when we acquire lock. we only need to check the precondition when we are about to submit a transaction which has some side effects.
That depends 100% on what the intent of the code is. For instance, if you are currently processing a read and you observe that the OSD epoch changed, you have to drop the read on the floor immediately. You can't return a result.
Yes, because we are writing to the client side.
Yes.
Which is visible from the outer world.
And also because peering probably is already fucking with the data on disk, and you can't read it anymore.
Right, it's invalid.
So I'm sorry, but this is a general problem. We do a bunch of asynchronous things, and sometimes a chain of asynchronous things becomes no longer a good idea. This is true in a number of different ways in a number of different places, but it all boils down to the same basic concept. Is it still okay for me to be doing what I'm doing? Sometimes it's checking a flag. Usually it's checking the OSD map epoch, but like there are a bunch of wrappers in classic OSD that solve this problem. If you try to be more or less general than that, it's going to turn out to be a waste of time.
I just want to be more specific instead of adding the hook everywhere we acquire the log.
You don't have to add the hook everywhere. For instance, you do need a way to say there is no hook here. But the hook will be different in different contexts. This is a tool for use by the person writing code. It's often useful, and it's not necessarily useful for the same thing every time. But it's often useful.
If we want to embed this into an iterator as a must-have,
it's not a must-have.
The developer have no choice anymore.
Okay, guys, it can't be a must-have. Which is why, I said early on, I would actually rather this be a wrapper. I would rather it be the case that this just like every time you put in a callback, you have to remember to wrap it with a guard. But you guys decided you didn't want to do that because it might be too error prone. But remember, that's how the existing classic OSD code works. You have to remember when you reacquire a lock to go and recheck whatever it was you needed to check. So we have a ton of code that works that way already, and it is fairly error prone, but we did live with it. It did work.
Yes, we could do a opt-out way.
That's not opt-out. That's just there is no support for this. You have to roll it your own. You just have to, every time you type save them, the first thing you have to do is check that the condition is still true. Like with the current code, we already have the ability to say, as part of an error rater, there's an e-interrupt error here. That's possible, right? And as soon as you see that you're no longer supposed to be running, you simply return the e-interrupt error and to let the caller deal with that, which almost certainly means dropping it on the floor, right? If a request handler kicks off a chain of continuations that's supposed to return a read and it gets back e-interrupts instead, that means, the OSD map changed. Big deal, right? So that support is already present as part of SeaStor Future even. You don't even need error rater for that. The question is, do we automate the thing where we check the flag? And again, I would prefer a library solution to this. Embedding it into error rater is only useful if it makes it less annoying to use. But if it turns out to be very difficult or has a large amount of performance overhead, remember, we do have the option of just writing the code every time. We have to be aware that it's there anyway. Allowing ourselves to forget it could be very dangerous.
We could add
otherwise
hookable iterator.
Well, yes, and if you can find a way to make a hook that accomplishes this goal, by all means. Keep in mind, however,
there's one thing.
Keep in mind that the condition may shift over the duration of an execution pathway.
Okay, I'm buying I'm buying that we need in many places that we need at the taking machinery. Sure. I'm asking now about concrete implementation. Iterator got a lot of extra. It got 2 extra parameters, template parameters. One is, of course, the hook, the interrupt condition itself, Second one is is some kind of extra distinct set of not errors, interrupts. And I understood that this extra parameter, the distinct errors, is necessary for the sake of distinguishing in, let's say, hand all same way or assert on all or something like that. But we have an abstraction in Erator. We have an abstraction of errors. It's the template I just pasted in. It's the error T template. And currently there are two implementations. One is the unthrowable errors, the very fast, the very simple thing. Second one is about complex stateful errors. I wonder whether those actually interruptions, those gizmos those interruption indicators shouldn't be glued at this level. Joshua, have you tried poking with error T? Maybe adding some extra methods to indicate its error or something like that at the level of error T?
Oh, I haven't tried that, but I think I can try that now.
Are you trying to track statically the set of possible? Is there? Does your? Yeah, it does. Okay, never mind.
Excuse me?
I don't quite follow you.
Wait a minute. This has to wrap the dot. Never mind. Go ahead.
I'm not sure how to encode this precondition in the error returned by Erator. It's supposed to be a check right before we execute the task passed down to the Erator.
I think that the extra set, the set of interrupts, the set of distinguished errors were introduced mostly for the sake of all same way and to differentiate between what is an interrupt, what is an error. But this has been made at the level of the Erator itself. Maybe it should be made one layer below, at the layer of particular error. And then things like all same way would query particular error. Mr. Error, are you true error or just an interrupt?
Okay.
Interrupt specifier.
I'd rather. Okay, why not? I don't totally understand why this works this way, Johan. Well, maybe I'm confused. But why does this need to be integrated into Future at all? What I see here is you're returning a thing with a .then method and eventually a .toFuture method. So what does that have to do with Future? You could wrap literal, it just needs to have a .then method. It doesn't need actual, the thing it returns doesn't have to know that it's in an interruptible future. Every one of these .thens could have baked in the check. I'm not following.
OP.
Sorry?
Just like how we handle a operation. We have
correct. Granted, that's not a very
execute OP in it.
Yeah, that's turned out to be not all that comfortable a library to use, but nevertheless, this isn't any better. This is what I thought we do originally. This is why I thought we could just use a wrapper. So why does this need to be baked in?
I still don't quite follow you. I thought the interruption check should be in the continuation. And
Yes, yeah, but it could just be in the lambda, right? You could transform the lambda.
I see your point.
That would be the library approach, right? But we didn't want to do that because it would be irritating. So the next approach would be to create a sort of a super future, which simply wraps errorator and has a .safe then or then method, which has nothing to do with errorator's .safe then method, whose only purpose in life is to pass the relevant lambda through to the wrapped future and just, inject the condition check ahead of it, which I thought was what you were doing here, but it appears not to be.
I thought I tried your way in the past, back in July, and first let me confirm that what you mean is that we wrap the lambda, and we wrap the lambda, and in the wrapper we check the interruption condition, check the interrupter condition.
That would be the simple version, yes. But you could go one step further. You could say, okay, so I'm going to take whatever this current future is, and I'm going to wrap it in an interruptible wrapper, right? That wrapper contains a future and has a .safe then method. And you can then chain lambdas onto it. But unlike an errorator, when you call safe then on this thing, before it calls safe then on its contained errorator, it first uses the Boolean predicate. You've passed it.
I thought I tried this way, but
Fairly
it seems that. Excuse me.
I'm fairly certain that should work. You were saying that?
Yeah, I tried. That will work, but back in July I tested, and it seems that it might involve much performance overhead, and
yeah, I don't care about that. Do it that. Let's do the simple thing. That way we can stop arguing about errorator.
Okay, so we put the performance at the second place.
No, it means that today, right now, in September of 2020, having a functioning way to write code is more important than a few percentage points of performance. The thing is, once the code is written that way, we can actually go back and change it later if we come up with a more performant way of doing it. But today, right now, I'm not even convinced that it'll show up in a real benchmark.
Okay, I see your point.
Until we have profiling that shows that it's important, it's not worth arguing about, I think.
Okay, I see your point. I will try that.
Johan, what was performance regression back then? When you were using the wrapper error?
I have to look it up, and maybe I can send it in the email. Sorry?
Okay. I'm just guessing what the performance regression would be, like 30% or so.
I think I can send it in the email later, and I don't have it at hand.
No worries, thank you.
Okay, so I think I will send the performance test result in the email later, and we can make a decision and in the email, or right now we make decision on wrapping up the lambda way, the Samson way.
Those two things should be equivalent. They do the same thing.
Okay.
I mean, unless I'm missing something, the compiler should be able to figure out that those are the same thing. You can fully template the builder. It knows statically what the lambda is. It's going to do moves. There's no reason why it would be more expensive, one way or the other.
Okay. I will.
Could be actually less expensive, I believe.
Yeah, I mean, I'm just not convinced that I care about that level of difference. Like,
okay.
After we have profiling, we can make changes. It's not like we're tied to one particular version of this for all time.
Okay.
Anyway, let's ensure we are on the same page. You are thinking about actually the correct errorated future has the same method. It takes, there are multiple variants, but the one interesting is the one that takes value function and the error function. And you are thinking about...
Just one quick thing. Don't call it safe then, call it interruptible then. or int them or something. Just so we're totally clear. We want readers, we want
Okay.
readers, hang on, no, seriously though, we want readers to know that there's code they're not seeing. That's important. But yeah, it would take, yeah, the error function and the other function, just like now, would pass it straight through unmodified, except for adding this predicate to aerator.
Of course.
This takes
And
aerator
the
off,
decorate is
aerator doesn't have to be modified at all.
And that's the question. That's the place where I wanted to actually introduce some kind of hooking into aerator. Just take a look. The decorate predicate here can be actually parameter, a template parameter to aerator. That was the idea about hookable aerator, and this
Yeah, but you
could.
have to pass it through every time.
No, you don't need to pass every time. You need to pass. You need to specify. You need to specify the decorate only at the time of aliasing the aerator, and actually this would lead to generalization of aerators. Hookable aerator, or
Maybe,
well,
but
better name is necessary.
like it's not obvious to me that it would be more performant or simpler. I think maybe keeping, like you mentioned before, that you didn't really like saddling aerator with the extra responsibility, and I agree with you. I think having it be separate is better.
Okay, I started considering giving small relaxation here. The idea of hooks, of introducing hooks to aerator to get, let's say, pure aerator, interruptible aerator, whatever aerator.
Okay. You could talk to Wei, and then you guys can decide what you want to do. Either way.
Okay.
I don't
Anyway,
think it's helpful, though. I think it's just more complicated. I don't think hooks are bad. I just think in this case, hooks are not intrinsically good either.
Okay, Sam, at which particular layer, just to ensure we are on the same page, at which particular layer you wanted to add, who should be responsible in your idea to add the check to wrap the lambda?
The user, when you're creating a callback chain, is responsible for either by hand wrapping every lambda as they pass in the safe then, or they could use a builder, as I am suggesting here, which would work basically like what I'm seeing here in this PR, where you would specify a builder.
Okay.
Hang on. It would take as an argument an incoming future, and then it would take a continuation chain, a specified set of them, and say for each of the continuation handoffs in this chain, please insert this check before you continue. There are some catches to this. There would be nested futures. So let's say you call into SeaStor, and from your perspective, it's one continuation, right? You say, go do a read, and then you get the read back, right? One continuation. But in real life, it's actually a whole set of continuations. SeaStor may do several things in the background in the process of serving that read, making multiple independent reads, but you don't ever see any of those continuation calls. As a result, whatever your Lambda predicate says is the stop condition won't actually be executed until control returns to your handler, not any of the SeaStor handlers. And I claim that this is actually a good thing, because SeaStor wouldn't necessarily be prepared to handle an arbitrary interrupt condition from above its own interface, which is something I'm worried about with this case as well. So there's the component problem, which I think, so in other words, the thing I'm proposing solves that problem too. It's one of the reasons I don't actually think it's a good idea to mix it into aerator, not unless, we have to. And if we do that, we have to be very careful. Do you understand what I'm getting at?
Yeah,
So in other words,
the most pain.
An OSD map change is of no interest whatsoever to SeaStor. So if SeaStor is
Sorry?
an OSD map epoch change is of no interest to SeaStor. If SeaStor is in the
I
process of
see.
performing a sequence of reads in order to fulfill a single atomic read request from the OSD, it would be very awkward if arbitrarily at some point during that sequence, its continuation stopped firing on that read. It would mean that SeaStor would have to guard against arbitrary, what would you even call it? Like arbitrary points where they just don't get any further calls. The same would be true of any subcomponent, and I think that's not good. I think subcomponents should only have to worry about predicates that arise within that component.
Sam, in other words, like an onion. So in the innermost, like in SeaStor layer, we should just worry about SeaStor, and the
Exactly.
PG layer we should only worry about PG. Yeah.
Right. And it's both because it's okay to do it that way, and also because it's simpler to do it that way. Clearly, it does waste a little bit of resources. If you could interrupt a read that no longer needs to be done early in SeaStor, that would theoretically save resources. So that would be good. But interrupting a transaction partway through, that's not so simple. There's a point in a transaction at which you have to finish it. You can't just stop. Right? There's stuff in cache that needs to be finalized. There are open things that need to be closed. There's work to do. Otherwise, other writes will be blocked indefinitely, or you have to find some way to handle it. In the PG, we handle this by, or up in the OSD code, you'll notice there are a lot of cases like that. When you observe that your predicate is now false, you need to release your op context and release any locks you have on objects. There is it's not just you drop the request on the ground, there's cleanup to be done. So anyway, I'm sorry I didn't take a closer look at this before, but it looks to me like we could really just do this as a wrapper.
Yeah, that has. You mean the approach with decorating before passing anything to save then?
As far as Aerator is concerned, yes, but if we want to make it more ergonomic, we can create something like this IF builder that creates an intermediate facade object that just does it for you.
That's the idea.
To me, those two things are the same approach, just with slightly different ergonomics. One of them is a little.
Yes. Now we are saying about the idea of calling, of decorating inside. Let's say save then. And
well,
this actually will.
I think that's not inherently better. I think it has pretty much the same properties.
Except for ergonomy. That's all.
Well, no, actually, it's not quite, and this is the reason. So it's easy to indicate where such a predicate comes into play. It's the first safe then call where you add it, right? But you need a way to cancel it later, and you need a way to indicate which safe then calls it applies to. Do you see what I'm getting at?
Not sure.
So here's the thing. When you're building up one of these futures, you could think of it as being really linear, right? It's just a sequence of callbacks. But if you think about it, they're actually nested. Like if one thing that looks like one asynchronous operation up at the PG.
I see. That's
like 10 different.
Sorry, wait a second.
Down in SeaStor. So you would not only.
You mean something like?
Please let me finish. You would not only need a way of adding one of these decorators to a safe then. You would need a way of indicating what class of safe then it applies to, and when does it stop applying. Because you only want it to apply to continuations that actually are attached in PG code in that case. And it's not exclusive. SeaStor might have its own such conditions that it needs to apply further down. And in those cases, the correct answer isn't to completely stop the task. It's to return an interrupt error to PG. Because that's not PG's own That wouldn't be PG's own predicate. That would be SeaStor. So from PG's point of view, this is actually a SeaStor error.
I see.
Up at the very top level, generally, the PG version at least, resolves to a messenger handler error. It's just a messenger handler error we don't care about. So I don't actually think that this should live in error rater. It would be complicated to do it that way, and you would need to add a bunch of nested structures that would be kind of hard to reason about, and probably would have a performance overhead in the case where it's not used, which is not ideal. I would rather pay a modest performance penalty in PG where we actually need it and not pay it anywhere else. And I'm not saying I don't ever want to add decorators to error rater. I'm saying that in this case, the specific thing we need, it's not really helpful. At least not obviously to me. I could be wrong.
So Stan, if I understand you correctly, it's just like invoker, right? Just call the given invoker. Just call the given lambda and do the check, and if the precondition does not fulfilled, it could return an interrupt error, and we
You'll
can
notice that very
do whatever we need to.
If you go look at the OSD code up in PG backend.h, there's an interface concept called a blessed context.
Blessed context, okay.
And if you take a look at it, all it does is it encapsulates the PG active and whatever epoch change check that happens throughout PG so that the backend implementations don't have to know about it. That's all we're talking about here. We're just talking about different ways of making that less annoying to do or more difficult to forget. The main advantage of the builder concept is that for at least anything within that chain, a user would have to go to some effort to forget to do it. That's the main advantage. Also, it avoids one extra level of indentation, but whatever, it's not that important. Does that make sense to you, Zuan?
Johan, what do you think?
Yeah. Yeah, I think that makes sense, and I can try that.
Okay, I'm really sorry I didn't look at this earlier. I think I could have saved you some time.
Oh.
I apologize.
Don't mention it.
So anything else? Nope.
There.
Okay, thank you guys, and later. Have a good one.
Thanks. Have a nice day. Bye.
You too.
Bye.